This is the machine used for producing that high voltage lamp explosion, and soon to be high voltage exploding something else. Or would I just show how it works? There's the chamber of things we want to not be there anymore. It's basically a capacitor bank. We got 6 of these things. They're each, I can get the label. Here we are. 100 microfarad-ish, 2.5 kV. And these are hooked up in 2 banks in parallel, and those 2 banks are in series. So what we've got is 150 microfarad, 5 kV bank. We're charging it somewhere between 4 and 5 kV, we don't know exactly. One side goes into the box, the other into the box via this is actually a form of triggertron. This second transformer here generates the 8 kilovolts it needs just to strike the arc there, and it is just triggered spark gaps, so little arc jumps there and that causes a big arc jump across there, and you can see by the scarring around it's quite a nice spark. It's the only way we could find to handle the kind of current this thing puts out. We tried a pneumatic switch and it kept blowing the cylinder out the end. The high power source and the brains of the system all reside in this box here. We try not to go in here too much. Old microwave oven transformer is the high voltage supply. That's 4 kV, so ish, probably 4.5, I don't know. And this goes through a voltage doubler configuration with these 2 diodes. They have to be isolated during firing, so charge relays and discharge relay. Those are both old Soviet made radio antenna parts. Control unit is this sheet steel enclosure. It has to be because the magnetic pulse this thing puts out will crash most electronics at that range. And all the rest of it is just a tangle of power supplies and relays operating relays. It does the job. It's got a discharge resistor on the side, which is why we always charge the thing up twice when we fire it. The first time is a test of the discharge. So yeah, it's fairly basic. The control command comes in through this line here, which is a fibre optic. So the controls are completely electrically isolated from the high voltage side. Just turn it on. There's no power to the high voltage gear, so this is quite harmless. It's a unidirectional link. And the firing sequence, that disconnects the discharge / safety relay. That charges it up. Cut charge. That discharges through the discharge resistor, so we can see it's all working. Disconnect discharger. Charge up. Disconnect charger, and bang. There are a few interlocks, so you can't fire it while the charge is connected or charge it while the safety's not set. And we are about to, well, run more stuff up. So videos coming soon.